Here's how stoichiometry works, but with a BLT sandwich. 3 pieces of bacon plus 1 piece of lettuce plus 2 pieces of tomato plus 2 pieces of sandwich bread is going to give us 1 BLT sandwich. Like in a chemical reaction, this is our product and all of these are our reactants. So let's solve the first one. It says, how many sandwiches can you make with just 30 pieces of bacon? Now, when you have a question like this in the context of stoichiometry, you always assume that whatever's not mentioned is unlimited. So let's say you've got a whole bunch of everything, but you only got 30 pieces of bacon available to you. That's going to limit how many BLTs you can make because every BLT is going to need 3 pieces of bacon. So let's see how this works using something like dimensional analysis with the stoichiometry. Start with what you know, in this case 30 pieces. So we have 30 pieces of bacon. I'm putting that over 1. From there, I'm going to use these coefficients. So I use a 3 in front of bacon, and notice I was asking about sandwiches, which is the BLT. There is an invisible 1 in front of BLT. So you need one BLT can be made from all of these things, just like there's an invisible 1 in front of lettuce. We don't usually show the ones, but I'm going to draw it in for the BLT. So I'm going to go from bacon to BLT, and according to these coefficients here, there's a 3-to-1 ratio. 1 BLT requires 3 pieces of bacon. So I can cancel out the B, and I can circle BLT because that is what it's asking about, how many BLT sandwiches. And then we can do our math here. 30 times 1 divided by 1 times 3 is 10. We can make 10 BLTs if we have 30 pieces of bacon. But this, of course, assumes we have unlimited everything else. If we didn't have any tomatoes or lettuce, we wouldn't make any sandwiches, right? So that's one thing you got to know about stoichiometry. There could be lots of different reactants or even sometimes products, and you just got to focus on usually 1 or 2 things at a time. Now, there are situations called limiting reactants or limiting reagents where you do have to kind of do a little bit more, but it's really not that bad. Let's do the second one. How many tomato slices are needed if we also use 22 pieces of lettuce? So 22 pieces of lettuce is right here. I can put that here, 22L over 1. Assuming everything else is not a factor here, I'm going to go from lettuce to tomato slices. Now we use our coefficients again. Looking at the 2 in front of the tomato slices and then the 1 in front of lettuce, we're going to use the 1 and the 2. So we're going to put a 1 in front of L and a 2 in front of tomato. L are going to cancel out, so L and L are gone. Tomatoes are not, because that answers the question, how many tomato slices? Then you can put equals into your math. 22 times 2 is going to give us 44 tomato slices. So this effectively answers the question, if you also happen to use up 22 pieces of lettuce, how many tomato slices will you be using at the same time? So since we need 2 tomato slices for every 1 piece of lettuce, we're going to use twice the number of tomato slices compared to lettuce slices. That's the gist of how stoichiometry works, except when they're real chemicals, you're going to still use the coefficients in front of those chemicals, and you're going to use those in your ratios. By the way, this same sandwich analogy is helpful for understanding limiting reactants or limiting reagents, where one thing may run out before other things run out, which limits how much of the product you can make. So here is the pantry. The pantry has 900 slices of bacon, 2,000 pieces of lettuce, 800 slices of tomato, and 1,000 slices of bread. Now, you're going to try to make as many sandwiches as possible based on what you have here, and they have to be complete sandwiches. So here's how it works. You basically need to do stoichiometry with every single thing to completion, which is to the BLT. So let's first deal with the bacon. I have 900 slices of bacon available, but I know that according to the equation to make a complete BLT, to go from bacon to BLT, I've got to use my ratio. There's a 3 and a 1, so I'm going to put 1 over 3. B is going to cancel out, BLT will not. 900 divided by 3 is 300 BLTs. So ignoring everything else, I can make 300 BLTs based on the amount of bacon that I have available. So far, so good. Is there anything that's going to limit us, or is that the limiting? Let's find out. Now let's do the lettuce. So for lettuce, I have 2,000 slices, so 2,000 L over 1. According to our reaction, I'm going to go from L to BLT using these numbers, the 1 in front of L and the 1 in front of BLT. It's a 1-to-1 ratio because every BLT has just 1 slice of lettuce in this equation. And that's going to give us 2,000 BLTs. Now we have a question here. Can we make 300 BLTs or 2,000 BLTs? So far, ignoring the other 2 things, we can only make 300 because it's our lowest number. The 2,000 would be great, but that would depend on us having unlimited amounts of everything else, or at least enough to cover it. Now let's do the tomatoes. So we've got 800 slices of tomatoes, put that over 1. I'm going to go from tomatoes to BLT. Tomatoes will cancel. The ratio I'm going to use here is the 2 and the 1. So every 1 BLT requires 2 slices of tomato, which gives us 400 BLTs. So far, bacon is what's limiting us. If we want to make more than just 300 complete BLTs, we need to order more bacon. But let's see about the sandwich bread. So for the fourth one, the fourth stoichiometry, so to speak, we've got 1,000 sandwich breads. Over 1, I'm going to go from sandwich bread to BLT. And the ratio here is a 2 to 1. So every 1 BLT requires 2 sandwich breads, which means that if we have 1,000 slices of bread and every sandwich requires 2, we would be able to make 500 BLTs. So only one of these can be our real answer. We can't make 300 and 2,000 and 400 and 500. So in reality, because bacon is going to run out first, bacon is considered to be the limiting reagent or limiting reactant. So that's how it works. When you have multiple things you have to consider, you have to do stoichiometry for each of them to see which one will run out first. Your answer for which one is the limiting reagent is going to be the one that gives you the least amount of product. So because of the 900 slices of bacon, we can only make 300 BLTs. Notice here also that 900 was not the smallest part of our inventory. We actually had fewer slices of tomato than slices of bacon, but because of the ratio, because we need more bacon per sandwich than tomatoes per sandwich, it's the reason why it ran out first. Everything else is considered the excess reagent or the ER. But in reality, most of the time, you only have to concern yourself with finding the limiting reagent when you're first starting out with problems like this.